Do you want to know how a NAND logic gate works? Understanding its truth table? Then this video is for you. But before we continue, I want you to please like and subscribe, because it really helps a lot by growing the channel. You can also leave a comment if you have any questions or something to say. Thank you. This is the NAND logic gate we designed with transistors to make it easy for your understanding. What is a NAND logic gate? A NAND logic gate is a digital circuit that can have either two or more than two inputs. But basically, we would be explaining the one with two inputs. This is the symbol for a NAND logic gate. Its inputs are labeled A and B. The output is labeled Y. As you can see from the circuit diagram here, the circuit is built with two NPN transistors. The inputs are labeled as input A and input B. And you can also see the output labeled Y. In this circuit, when we close any of the switches, it indicates that the input is true. But when we open any of the switches, it would indicate that the input is false. When the LED turns on, it also indicates that the output is true, but when the LED turns off, it indicates that the output is false. So we would be representing the true with 1, and represent the false with 0. This is the truth table for a NAND logic gate. A and B is the inputs and Y for the output. There is a formula for drawing the truth table for a logic gate, which is 2 raised to the power the number of inputs. So here we would have 2 raised to the power 2, which is equal to 4. So we would have 4 boxes in each column for each input. Then we would have the inputs labeled as you can see on the screen. All the zeros represents false, and all the ones represents true. So when we mention true, we would label it as 1, and when we mention false, we would label it as 0. So we would get the output for this logic gate by the principle of its operation. The principle of operation of a NAND logic gate is, the output would be true if one input or all inputs are false. So where we have all the inputs to be false, the output is true. And where we have one input to be false, the output remains true. But when all the inputs are true, the output would be false. Now let's test the circuit. When all inputs are true, the output would be false, as you can see that the switches are closed and the LED is off. But when one input is false, the output would be true. And when all inputs are false, the output remains true. This is the same circuit we built on a breadboard. When all inputs are true, the output would be false, as you can see that the switches are closed and the LED is off. But when one input is false, the output would be true. And when all inputs are false, the output remains true. That is all about today's video. Please like and subscribe to our channel if this video is helpful. You can also leave a comment if you have any questions, or something to say. Thank you.